Mark, the red graph, and Iris, the blue graph, are driving two separate cars to San Francisco. They begin the trip with full gas tanks. The amount of gas in gallons that remains in each car depends on the number of miles driven, as shown to the right. After how many miles will the tanks contain the same amount of gas? If the number of miles driven is more than this, which car will have more gas in its tank? So let's take a look at the graph and make sure we understand it first. So we see on the right-hand side that the scale is labeled miles driven, and we've got 0 to 600. So the scale goes from 0 miles to 600 miles driven. And then on the vertical axis, it's labeled as gallons of gas in the tank, and it starts at 0 and goes all the way up to 60. So as mentioned in the instructions, Mark is the red graph and Iris is the blue graph. So here we have this line. The red line is Mark's trip, the record of Mark's trip. And in blue, we have a record of Iris's trip. So it says here, after how many miles will the tanks contain the same amount of gas? So the same amount of gas, remember this vertical scale is the gallons of gas, and we can see at this point right here, that's when the gallons of gas are the same. And if we go down here, we can see that at 250 miles, the amount of gas will be the same. So we know that after 250 miles driven, the amount of gas in the tanks is the same. Okay, so let's take a look at the second question. If the number of miles driven is more than this, which car will have more gas in its tank? So we're talking about the number of miles now. So this is on our X scale. Is more than this. So we're talking about to the right of that point, to the right of 250 miles. Which car will have more gas in it? So on that portion of the trip, you can see that the red line is higher than the blue line. So during that portion of the trip where you have driven more than 250 miles, you can see that the red graph, which is Mark, has more gas in the tank because it has a higher Y value. Remember, the Y part is the gallons in the tank. So Mark's car has more gallons of gas after 250 miles driven. Determine the real solutions to the system of nonlinear equations. This system has two equations, x squared plus y squared equals 146, and x minus y equals 6. So as I'm looking at it, what I like to do with systems like this is to get a little graph representation first so I can get an idea of how many solutions I might end up with. So I've got this first equation, which is x squared plus y squared equals 146. This is the equation of a circle. And the second equation, x minus y equals 6, is a linear equation. And if I draw a circle and a line, I might get two intersection points, which would give me two solutions to the system. But this circle and the line might also be drawn in a way that the line is tangent to the circle, and that would only give one intersection point and one solution to the system. Or the circle and the line could miss each other and have no intersection points, and we might have no solution for this system. So as I'm working through this, I am expecting to either get two solutions, one solution, or no solution to the system. So then I'm going to decide which method I'm going to use to solve the system. Now, looking at these two equations, I can see that the x terms are not like because we have an x squared and an x, and the y terms are also not like terms because I have a y squared and a y. So I'm not going to use the elimination method for this example. What I'm going to do is the substitution method, and I think it's going to be easiest to take the second equation, x minus y equals 6, and let's solve for x. I'm going to add y. That's x equals y plus 6. And I'm going to substitute that into the other equation. So we're going to substitute y plus 6 in for x because this equals x. So that would give me the equation y plus 6 squared plus y squared equals 146. And I'm going to multiply y plus 6 squared, that's y plus 6 times y plus 6. And when I multiply that out, I'll get y squared plus 6y plus 6y plus 36 plus y squared equals 146. Got some like terms I can combine. Y squareds combine together to become 2y squared. 6y and 6y combine to be 12y. And I've got plus 36 equals 146. So I can see that this is a quadratic equation. I'm going to move all the terms to the same side. So I'll subtract 146. And that gives 2y squared plus 12y equals a negative 110 equals 0. And I'm going to try to solve this quadratic equation by factoring. I notice all these numbers are even, so let's factor out a 2. I'll be left with y squared plus 6y minus 55 equals 0. And let's see if we can factor that. So we've got y and y. And factors of 55, we don't have very many. That's 1 and 55, 5 and 11. 5 times 11, the difference of that is 6. So that looks like it's going to work for us. So we can use a plus 11 and a minus 5. That'll create the right middle term so that we can get 6y in the middle. We're going to set each of these factors equal to 0. Y plus 11 equals 0. Y minus 5 equals 0. And that gives y equals negative 11. Y equals 5. So this is part of our solutions. These are the y coordinates of our solutions. We now need to find the x coordinates. And we can use this equation that we had earlier to find the x coordinates. So I'm going to substitute that -11 in for y, and I'll also substitute that 5 in for y. So if y is equal to -11 and x is equal to -11 plus 6, that means x is equal to a -5. So we have one solution being -5, -11. For the other solution, y is 5 and x is equal to 5 plus 6, that's 11. And our other solution is 5, 11. No, I got that backwards. Sorry about that. The x coordinate is 11 and the y coordinate is 5. So those are our two solutions, -5, -11, and 11, 5. The diagonal of a TV set is 26 inches long. Its length is 14 inches more than the height. Find the dimensions of the TV set and show your work to receive full credit. So we have a TV set which is going to be rectangular. The diagonal of the TV set is 26 inches long. Its length is 14 more inches than the height. So let's label the height as x, and its length will be 14 inches more than that height. So we're going to be able to find the dimensions of the TV set by using Pythagorean Theorem. So this creates a right angle, and using Pythagorean Theorem we know that we can relate the sides of the triangle. So with Pythagorean Theorem we take the square of the legs. So these two right here, this side and this side are the legs, and the side that is opposite of the right angle is called the hypotenuse. So we do the sum of the square of the legs. So that's what we have here. The sum is adding, and we do the square, raising each to the second power. The square of the legs is going to equal the square of the hypotenuse. So this gives us a way to relate the sides, and we're going to be able to solve for x. So we have x squared, and we need to multiply out x plus 14 times x plus 14. We need to know what 26 squared is. That's 676. To multiply this out, we have x squared plus x squared plus 14x plus 14x. And I need 14 times 14, that's 196. Let's combine like terms. X squared plus x squared, that's 2x squared. 14 plus 14 is 28x. And once again, we have a quadratic. I'm going to subtract 676. And we have 2x squared plus 28x. And let me do 196 minus 676. So negative 480. And what I have here is a quadratic equation with really big numbers. And I usually solve this with factoring, but I think I'm going to change it up this time and just to show a different method, I'm going to solve this with the quadratic formula. So with the quadratic formula, these numbers are very large, and it will make the solving of the quadratic formula a little bit messy. So to help myself a little bit here, what I notice is that these numbers have a common factor. So I'm going to factor that number out first, make the numbers a little bit smaller, and it'll make our quadratic formula a little bit easier to work through. So let's factor out that 2. We have x squared plus 14x minus 240 equals 0. And if you would like, you could also divide both sides by that 2 to reduce the equation to be x squared plus 14x minus 240 equals 0. And then we need to use the quadratic formula. We need to identify A. A is the coefficient of the squared term, which is 1. B is the coefficient of the x term, which is 14. And C is negative 240. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's start substituting this a, b, and c into the formula, and that will give negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 240. That's going to be a negative 240 all over 2 times 1. We have negative 14 plus or minus the square root, and we did 14 squared, 14 times 14 earlier. That was 196. And I need to do 240 times 4. That is 960. Negative 14 plus or minus the square root of 1,156 over 2. We want to see if we can simplify that radical. So that's a really big number, so I'm not familiar with factors of it off the top of my head. So what I'm going to do is I'm going to try to figure out some perfect squares that might be factors of this number. So remember, perfect squares are like let me fix that. Like perfect squares, 2 squared would be 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 6 squared is 36. So what I'm going to do is try to see if I can find some of these perfect squares that divide into 1,156. So I'm going to try, let's start with the 4. 1,156 divided by 4. Okay, that does divide it into 4 times 289. So that's going to help a little bit. 289 is smaller, but let's try into 289. We can get a perfect square. I just tried 9, that didn't work. 16 didn't work. 25 didn't work. 36 didn't work. How about 49? No. How about 64? Nope. Okay. Let's try 81. Nope. Let's see. 10 squared would be 100. All right, I don't think I have any more perfect square factors that can go into that. I've tried all these numbers. Let me try one more. 11 squared would be 121. Okay, so that might be as much as I can factor it. So it would be negative 14 plus or minus. And I can simplify this. Square root of 4 is 2. The 289 would stay inside the radical. And 2 divides into each one of these terms. So it's, excuse me, I apologize for that. Forgot to get a clean whiteboard for this problem. So 2 divides into each one of those and it becomes negative 7 plus or minus square root of 289. So we can work out those numbers in the calculator to see what the dimensions are. Negative 7 minus square root of 289 is going to be a negative number, and that doesn't make sense for the dimensions, so we're not going to worry about that one. We're going to ignore it. We're going to do negative 7 plus square root of 289. I'm doing this in my calculator here. Square root of 289 all right, I just I should have kept going higher on this. I should have kept going higher on that chain of numbers there, because square root of 289 is 17. 17 squared is 289. Okay, so negative 7 plus 17 gives me 10. So 10 is the height of the TV, 10 inches, and the, what do we call it here, the length is 14 inches more. And that's going to be 24 inches. So the dimensions of this television set are 10 inches in height by 24 inches in length. Determine the real solutions to the system of nonlinear equations. We have y equals x squared plus 9x plus 5, and y equals x squared minus 2x plus 16. So both of these equations are quadratic, and the graph of quadratic equations are parabolas. So I'm going to draw a couple parabolas together and try to see possibilities for number of solutions to this system. So we could have, the parabolas might be going in opposite directions like this, and that would provide 2 intersection points and 2 solutions for the system. You might have them, go something like this. So they might have one solution. They could be, maybe another way for one solution would be something like this. One intersection point, or they could totally miss each other. So we could have two solutions, one solution, or no solution for this system. Now, as I'm looking at this system, I'm trying to decide what method I might use to solve it. And it's looking like you could do substitution or elimination very easily. I'm going to try elimination with this example. And what I see is already the like terms, the y's are lined up, the x squareds are lined up, the x's, the constants are lined up. Most importantly, that equal sign is lined up. Because that's how this method works. You're going to add the equations together, and we need the equal signs to line up when you add them together. So because everything is lined up nicely, all I need to do would be to multiply by a -1 on this second equation, and the y variable will eliminate, and the x squareds will eliminate. So let's write the system in that way. Of y equals x squared plus 9x plus 5. When I multiply the second equation by -1, that would be -y equals -x squared plus 2x minus 16. And I'll add the equations together. The y's will eliminate, the x squareds will eliminate, so I'll have 0 equals 9x plus 2x is 11x, and 5 minus 16 would give me -11. I'll solve for x by adding 11 to both sides. That's 11 equals 11x. We'll divide by 11 to get x equals 1. And then I can substitute into either equation to get the y coordinate. So I'll use the first equation, y equals x squared plus 9x plus 5. X is equal to 1. And we get y equals 1 squared plus 9 times 1 plus 5. It's 1 plus 9 plus 5. And we get 15. So the ordered pair 1, 15 is the solution to our system. On this question, we want to solve the exponential equation. 5 to the x over 3 equals 22. We have a few different methods for solving exponential equations. The easiest method is to make the bases the same, which we're not able to do in this example. So we're going to have to use our other methods, the ones that work all the time on these exponential equations. We can either convert to a log, or we can take the log of both sides. Let's do both of them. So if I were to convert this to a log, let me write the word log, and I would use the base 5 because 5 is the base of the exponential. Now the log always equals the exponent. So the log is going to equal x over 3, what's in the exponent here. And then this 22 is what goes inside the log. So we have log base 5 of 22 equals x over 3, and we can solve this by multiplying by 3 on both sides. So we would have x equals 3 log base 5 of 22. So that's one solution, one way to solve it. Let's do it the other way, which is to take the log of both sides. We have 5 to the x over 3 equals 22. And I would do the natural log on the left and the natural log on the right. And once you introduce the log, you can use the power rule of logarithms, where you can move this log into the coefficient. This is x over 3 natural log of 5 equals natural log of 22. Now I need to solve for x, so I'm going to multiply both sides by 22. Multiply both sides by 3. That gives x natural log of 5 equals 3 natural log of 22. And I'll continue to isolate x by dividing by natural log of 5. So I have x equals 3 natural log of 22 over natural log of 5. Now these answers, they look different from each other, but they're actually equivalent because we can use the change of base formula to convert this base 5 that you see on the left to a natural log. And using the change of base formula, you would get natural log of 22 over natural log of 5, and these answers, as I said, are equivalent to each other. So our solution is x equals 3 natural log of 22 over 5. Determine the real solutions to the system of nonlinear equations. In this example, we have x squared plus y squared equals 16, and y squared minus 2x equals 16. So when I start these, I like to get a visual representation first so I can get an idea of how many solutions I might have. This first equation, x squared plus y squared equals 16, is the equation of a circle. And the second equation, y squared minus 2x equals 16, it is a quadratic, a parabola. However, this one is not oriented like we're used to seeing them because the squared is on the y, and so our parabola, instead of facing up or down, is going to face to the left or to the right. So this is going to be a quadratic, but the orientation is left or right because of the square being on the y. So if we draw a circle and a parabola in the same picture, you could have 4 solutions if it is oriented this way. Or if that vertex of the parabola is just touching the circle, touching the edge of the circle like this, you might only get 3 solutions. If the vertex of the parabola is inside the circle completely, then you might just get 2 solutions. And it's also possible for the vertex to touch the edge of the circle like this. That's only 1 intersection point and 1 solution. And we can also have the circle and the parabola being totally separate. So we could have 4 solutions, 3, 2, 1, or none for this system. So as we look at this system and try to decide how we're going to solve it, you're going to look for opportunities for substitution, opportunities for elimination. And what I see here is a y squared in both equations. So you could use substitution. You can solve for y squared and substitute into y squared. It's also an opportunity for elimination because we're going to be able, because those are like terms, we'll be able to eliminate the y squared. So let's try with substitution this time. I'm going to take the second equation, y squared minus 2x equals 16, and I'll solve for y squared, so I'll add 2x to both sides. That gives y squared equals 2x plus 16. And then I'm going to substitute that into the other y squared, the other equation, and that will give x squared plus 2x plus 16 equals 16. I have a quadratic here, and I'll move all the terms to the same side. That gives x squared plus 2x equals 0. And I can solve this by factoring. We're going to factor out an x. And I can set each factor equal to 0 using that zero product property. And that gives x equals 0 and x equals -2. And we'll substitute these x's in to find out what y is. So I'll use this equation right here. You can use any equation with two variables. I have y squared equals 2x plus 16. If x is equal to 0, then y squared is 2 times 0 plus 16. Y squared equals 16. And I can square root both sides to get y equals plus or minus 4. So I have x equals 0, and I got two y values. So that means two ordered pairs, 0, 4, and 0, -4. So we want to do that again with x equal -2. So if x is equal to -2, y is equal to 2 times -2 plus 16. That's -4 plus 16, and that's 12. And this is supposed to be a y squared. So I've got y squared equals 12. Square root both sides, and that gives y equals plus or minus. Now square root of 12, we're going to write that as 4 times 3. So the square root of 12 would be 2 square root of 3. So once again, we add one x, but we came up with two y, so that's two more ordered pairs, -2 and 2 square root of 3, and positive -2 and -2 square root of 3. So we've got four solutions to our system: 0, 4, 0, -4, -2, and 2 square root of 3, -2, and -2 square root of 3. For this one, we want to graph the following inequality. Y is greater than or equal to 76x plus 2. So this is a linear inequality. We've got an inequality because of the symbol here is greater than or equal to, and it's linear because both x and y are to the first power and follow that format of a linear equation. So when we graph an inequality like this, there's really two parts. The first part is the boundary. And the boundary will be replacing the inequality symbol with an equal symbol. So it will be y equals 76x plus 2. And that boundary line, you're either going to draw it solid or dashed based on whether you include the boundary line in the solution or not. So we've got this equal to. Remember, the boundary line is equal to. So that means that we want to include the boundary line, and including the boundary line means that we're going to draw it as a solid line. So we want to draw this boundary line solid to include the points on the boundary as part of the solution set. Now this equation, this linear equation, is written in slope-intercept form. That's y equals mx plus b. So we can use the y-intercept of 0, 2 and a slope of 7, 6 to get 2 points on the line and draw the line. So we're going to plot that y-intercept of 0, 2. I'm going to use the slope. The slope is that tilt of the line. So we're going to rise 7 and run 6. I'm counting in my head over here to get to this point. And we're going to connect those 2 points to create the boundary line. And remember, we're connecting them with a solid line because this boundary line is included in the solution set. Now, the second part of graphing the inequality will be the shading. And the shading is going to be on either the upper part, what's above the line, the upper part of the plane, or the lower part of the plane, below the line. And we have to figure out which side to shade on, so we choose a test point. And there's only one rule with the test point, and the rule is that it cannot be on the boundary line. So any ordered pair you want, anywhere in the plane, as long as it's not on the boundary line. Most people like to choose 0, 0 as the test point because the math works out nicer when you have zeros. So we're going to take that test point, 0, 0, and substitute it into our inequality. Y is greater than or equal to 7, 6, x plus 2. 0 is greater than or equal to 7, 6 times 0 plus 2. So that would simplify to be 0 is greater than or equal to 2. Now that is a false statement. So over here where the test point is, that came out false. And we call that a test point because that is going to tell us what is going to happen with this whole side. So this whole side, every single ordered pair on this portion, this region of the plane, will be false in our inequality. The other side will be true. So we want to shade the true side. We're going to shade, for this one, the upper part of that region. So now we have a picture which represents the solution set. So from this picture, we can tell that every ordered pair in this region will satisfy, will make this inequality true, and also every ordered pair on this boundary line will make this inequality true. Thank you for checking out my videos. Have a great day.